Hello, everyone. Thank you for joining our webinar. My name is Linda Johnson, Director of Marketing for Polyphaser and Transtector Systems. Today's presentation will be led by Transient Expert and Sales Director for Polyphaser and Transtector, Jason Nees, who will share basic requirements to consider in order to ensure power and signal integrity for land mobile radio applications.
Thank you, Linda. Again, my name is Jason. I'm a certified power quality expert. I have 17 years supporting Polyphaser and Transtector. Polyphaser and Transtector are two of the brands under the Infinite Electronics house of brands. Today, we're going to talk about mission critical communications and how they apply to land mobile radio applications. Transtector and Polyphaser, we have over 45 years supporting land mobile radio applications. We are a Motorola approved supplier, which means we do have a lot of products in the Motorola catalog that are both P25 and Tetra compliant. We have surge protection solutions to cover every application under the sun, including RF, AC, DC, and data line connections. We also have all of these products available for same-day shipping. Today, we're going to talk about a few different topics as they apply to the land mobile radio applications. We'll talk about surge events and their characteristics. We'll talk about surge protection technology for all of the applications, RF, AC, DC, and data line. We'll talk about surge protection technology components and how to select the proper technology for specific applications. Some of those applications we'll cover will be AC panelboard protection, Ethernet line protection, and RF protection. So what is this surge event we're concerned about? A transient or a surge is a microsecond event. It reacts faster, or it is faster than a fault or an overvoltage, which often lasts for seconds or minutes, and a transient event will pass right through a fuse or a breaker. So we have to have components that are designed to react in nanoseconds in order to protect our critical equipment from transients or surges. The kind of problems we see from surges are either destructive, where we'll see equipment catch on fire, smoke or carbon may expel. We'll see damage to the equipment, where we may see a board level component that's damaged by a surge. Or you could see equipment get degraded over time, where we see multiple low level surge events take a device that you might expect to get 20 years out of, and you only get 10 years out of it. So we have to have these devices that are designed to react just above the nominal voltage of the equipment you're trying to protect. This illustration here does a great job of showing what exactly that is. So when you have a normal AC sine wave coming into a facility that suddenly sees a spike, that red spike you see there, the surge protector that is normally in parallel and sitting there doing absolutely nothing sees that spike and now reacts and diverts that energy to ground. So we want to make sure we clip that energy as soon and as quick as possible to protect all of the downstream equipment. So VPL, or voltage protection level, is an important criteria when evaluating surge protection devices for land mobile radio. The technology that's used in these devices is often one of the major characteristics of how that VPL, or voltage protection level, will occur. So gas tubes were one of the first devices we came out with. They're very robust. They can handle a lot of energy, but they degrade over time. And their turn-on voltage is relatively high compared to newer technologies. So we evolved in the industry and we came out with metal oxide varistors. MOVs are also very robust. They can handle a lot of energy. They don't degrade as quickly as a gas tube, but just like a gas tube, they do have a shelf life, and therefore they have to be monitored. A silicon avalanche diode is a non-degrading component. It reacts super fast, very low, and that may sound like the ideal surge protection component, but it's not as robust as an MOV or a gas tube. So there's no perfect surge protection component, but what we do here at Transtector and Polyphaser is we look at all the components available and we'll put them into the right application for the right product for the right application, or we'll create what we call a hybrid circuit, where we'll put two of the components together to give the end user the best of the both worlds. AC panel boards are probably our first line of defense. The conductors coming into a building from a utility line are large and can bring a lot of energy into the facility. The utilities themselves are often providing power that is not of the highest quality. And then lighting is also predominantly populated onto utility lines and can enter facilities through those utility lines. So it's very important to place protection at the main service panel coming into a 911 critical facility. And when you're doing this, you want to place that protection as close to the service entrance panel as possible. We want to minimize the lead lengths between the panel board and the surge protection device. In the land mobile radio world, we categorize the surge protection devices we can use at service entrances or panel boards as either a 2B or a 2A device. This is a recent change that was put into effect just a couple of years ago to line up with the UL 1449 category codes that are used for surge protection devices. So the 2B device is what we call an MOV only device. It only has metal oxide resistor modules or components inside of it. It's very robust, but it doesn't have that silicon avalanche diode component in it that gives you the low turn-on voltage. A 2A device is an SAD MOV hybrid device that has the best of both worlds. It has that silicon avalanche diode device that turns on very low and doesn't degrade. And that's the component that's going to do most of your work for you. But your MOV is there as well in case you have a larger event. It's your backup. So we're showing off an example of a device here. It's our 2A device, which is a hybrid device. Apex IMAX 1101-808-1 uses SAD and MOV modules, as you can see in the picture here. Those modules, if one were to sacrifice, can be replaced very easily in the field with just 2 screws. Now, how do you know if those modules need to be replaced? There's both local and remote monitoring. So you can have remote monitoring via dry contacts and an open IO port, and back at your dispatch facility, you can know, oh, I have a surge protection device at a certain facility that needs to be replaced. Then when your maintainer goes out to that facility, they can use the local indication either via light or a flag to tell them which module needs to be replaced. Another application we're seeing used a lot in land mobile radio applications is Ethernet protection. This could be either because someone's putting Ethernet fed cameras out there, or perhaps it's radios for point-to-point mesh systems. So we see a lot of problems out there with the installations of this equipment, surge protection, you know, do I have a good surge protector, the grounding of these devices out there, are my components matched? Can I pass, if it's a PoE application, can I pass the type of PoE I need? Or we'll see wrong pinouts where people are putting connectors on the cables and not connecting them properly, and then we end up seeing signal and power degradation. So how can we address this? Well, Transtector has a line of Ethernet protection products that fix a lot of these problems we see out there. The threats we're concerned about, and the reason why we have to have the surge protection out there, are because we could see a couple of different things occur that could interrupt our signal or power. You could have a direct strike to a facility where you could have energy populate onto a down conductor, and if you have an Ethernet cable parallel to that down conductor, the energy could couple onto the Ethernet cable and interrupt your signal. We also have the effect where we have a nearby event that occurs, a lightning strike, and it energizes the atmosphere. And then that energy populates onto the Ethernet cable and can go either to the head end or the top of the power tower or pole and interrupt your signal. Then we have the event where the energy populates into the ground. And if you have 2 sites, a pole, say, and a head end, that the grounding systems aren't bonded together, then as the conductors at those 2 sites get energized, the Ethernet cable becomes the common connector and the difference in potential, and that can lead to signal and power interruption. So how do we mitigate this? We have to put protection at the top of the pole and the bottom of the pole. We recommend an outdoor rated surge protection device up at the top, close to the camera or radio, and down at the bottom, close to your head end equipment. These devices, designed by Transtector, are transparent to the system and are repetitive. You do not have to replace them after an event. However, if you did have a catastrophic event, the type of event that would lead you to have to go out there and replace that surge protection device, at least you're replacing your lower cost surge protection device and not your high cost radio or camera. A couple of solutions we have available that meet Motorola R56 standards are our CPX, which will be used down at the bottom in either a cabinet or rack or an enclosure. And the CPX is very versatile. There's a 4-port chassis you see here. There's a full rack. You can populate this with as many Ethernet protection modules as you need. These Ethernet protection modules are silicon avalanche diode based, and they have a very low turn on and they don't degrade over time. They also are mechanically, the components here meet the Motorola R56 standards in that we use a double lug ground connection so that you can get a good solid ground connection to make sure that any of that energy the surge protection devices see go to earth ground as quickly and effectively as possible. Up at the top of the pole, we recommend our ALPU F140. This is a hybrid device with a gas tube silicon avalanche diode protection circuit. You get the SAD in there doing most of the work. It's going to turn on very low and it won't degrade. However, if we see that catastrophic event, we have the gas tube in there to back up that silicon avalanche diode. So you get the best of both worlds, dedicated and isolated for every pair in that Ethernet cable. Now that protection is isolated from Transtector's unique gas tube shield to ground protection circuit. Now this is very, very specific to Transtector solutions in that anything that populates on the shield of your shielded cable will follow up to the ALPU F140, and using the isolated shield to ground protection circuit, it'll go to ground and not even get close to your copper pairs or have the ability to interrupt your power or signal transmission. So this device is rated for up to 100 watts, so it's future-proof for any down-road PoE applications we want to use, and it passes full gigabit Ethernet at a fantastic price point. RF protection. We still see a lot of RF protection being used out there, and land mobile radio applications are no different. Quite a few different polyphaser products are used all over the US for land mobile radio applications. And why is that? Well, the reason why is if you have an event populate on a coax cable, it can follow the shield and the center pin at 2 different rates and 2 different speeds. So when you have that event populate down the coax cable and come into the radio, if you don't have protection there, you're going to definitely have interrupted signal, and you could potentially have damaged equipment. So a polyphaser device will equalize the potential between the center pin and the shield. So now you have this great protection device that's going to keep your signal intact and protect your radio equipment as well. A couple examples of these solutions. One device that's used a lot in voice radio applications is the VHF50. It's an inductor-based surge protector, so it's always on. That inductor is tuned to recognize a DC event, a lightning event, and divert it to ground instantaneously, but past your RF or radio signal. The TSX we find used a lot in cellular applications from 698 megahertz to 2.7 megahertz. The TSX is also inductor-based. It has 2 tuned inductors on either side of the DC blocking capacitor. So those inductors are there for instantaneous turn on, and because it's inductor-based, no gas tubes, this is a maintenance-free device. You can put it out there on your coax line and not have to worry about checking it or maintaining it down the road. So to summarize what we talked about here today, we went over the importance of choosing surge protection devices that turn on as close to the nominal voltage as possible, VPL or voltage protection level. We want to make sure that you have a surge protection device with a really great VPL. We went over 3 different applications. We talked about your AC panel board, and we showed you an example of a hybrid surge protection device for Motorola land mobile radio applications. That was the Apex device with an MOV SAD hybrid surge protection circuit inside. We also talked about Ethernet surge protection devices and the ALPU F140, another device with a hybrid surge protection circuit inside, but that one, remember, was gas tube and silicon avalanche diode. And then the last product application we talked about were RF applications, where we went over the VHF 50 and the TSX NFF, which are both used for coax RF protection applications and provide instantaneous turn on and require zero maintenance. All of these products are available in stock, ready to ship the same day. And please, if you have any problems, issues, application questions, call us. We are ready and here to help. Thank you and have a great day.
Thank you, Jason, for sharing insights into surge protection for LMR or land mobile radio. To our audience, we would like to thank each of you for your time and hope you have found this webinar informative. If you have additional questions or would like further information on power and signal integrity for communication networks, please contact us directly to speak with a member of our technical support team at 1-208-635-6400 or visit our websites at polyphaser.com or transtector.com. Thank you.